Continuing with chapter 5.2 homework. This is number 19. Integral of natural log quantity squared over x. We can't rely on power rule. We don't have a rule specifically for natural log of x over x, so we look at u substitution. So usually if you see parentheses, your u value, your first guess will probably be what's inside the parentheses. So let u value be natural log of x. The derivative for ln of u is simply u prime over u, so the derivative will be 1 over x, cross multiply to solve for x, which is x du. Make our substitution. Natural log of x gets replaced with u. We square that. Denominator stays for now. Times, in terms of dx, replace dx in terms of du, so x times du. The x's conveniently cancel out. We're left with integral of u squared du. Here we can apply power rule. U squared becomes u cubed over 3. Integral sign drops out, du drops out, and we have plus c. And finally, we have to replace. We found our antiderivative. Now we replace u in terms of x, which is 1/3 natural log of x quantity cubed plus c. All right, 23. We look at u substitution because power rule alone is not sufficient. U value is what's inside the parentheses, which is x minus 1. Find the derivative with respect to x. So x becomes 1, 1 goes to 0, cross multiply, dx is du. So we're left with integral of 2x over u squared times du. So now the problem here is we can't continue with the problem. We can't continue until we find a way to get rid of this x. Okay, we need our integrand in terms of one variable, so we have to look at change of variable. Okay, we have a specific value for u, which is x minus 1, but if we solve for x, we can say x is u plus 1. So we can now replace x in terms of u, which is 2 times u plus 1 over u squared du. Okay, everything is in terms of u, so now let's see if we can clean this up to be in the form where we can apply power rule. So distribute the 2u through, distribute the 2 through, so 2u plus 2 over u squared, split up into individual fractions, and so we're left with 2 times 1 over 2 times the integral of 1 over u plus integral of 2 over u squared, which we can rewrite as 2 integral u to the negative 2. Okay, we're just trying to get it into a form where we have rules available to us to use. So we can use natural log here. So 1 over u is natural log of u, absolute value of u. And then this u gets replaced with x minus 1. But first we apply the power rule, which becomes u to the negative 1 over negative 1 plus c. And then the u gets replaced with in terms of x. All right, 25. Integral of 1 over 1 plus square root of x. We can't simply rely on power rule, so we look to see if we can let the u value be either the entire denominator or we can have it just be the 2x. Okay, so there's a bit of guess and check here. If we let the u value be simply 2x, we'll be left with 1 over 1 plus square root of u, which will not allow us to match the remaining function with a rule for us to use. So let's let the u value be the entire denominator in this case, which is 1 plus square root of 2x. Let the u equal to 1 plus 2x quantity to the 1/2. We go through power rule. Chain rule in this case, the 1 goes to 0, but the parentheses to the 1/2 becomes 1/2 parentheses to the negative 1/2 times the inner function's derivative, which is 2. The 2's cancel out, cross multiply. Well, we get du over dx is 1 over square root of 2x. Solve for dx, which is square root of 2x du. We make our substitution. The entire denominator gets replaced with u. The dx gets replaced with square root of 2x du. Okay, so even though we're able to clean this up a little bit, we're still left with the square root of 2x, which we have to find a way to eliminate. So we look at change your variable again. We know our assignment for u is 1 plus square root of 2x. If I solve for square root of 2x, simply u minus 1. So I make that substitution, 1 over u times u minus 1 du. Split up into individual terms, which is u over u minus 1 over u. Continue simplifying. Integral of 1 minus integral of 1 over u. This is simply using power rule, so 1 becomes u. Integral of 1 over u is simply natural log of u plus c. And now we're going to replace, we found our general solution in terms of u, so we just replace our u value in terms of x. So 1 plus square root of 2x minus natural log of the absolute value of 1 plus square root of 2x plus c. So this is an acceptable solution, but we can clean this up a little further because this plus c represents a constant. And our solution has a constant as well. So we can just merge this constant into this plus c and eliminate this 1. So we're just left with square root of 2x minus natural log of the absolute value of 1 plus square root of 2x plus c. All right, 27. Square root of x, integral of square root of x over square root of x minus 3. Again, we're going to try and let the denominator be the entire square root of let the u value be the entire denominator. So square root of x minus 3. Rewrite it in the form where we can apply power rule. We get 1/2 x to the negative 1/2 times 1. That's using chain rule to find the derivative. 3 is a constant, goes to 0. Rewrite it as 1 over 2 root x. Cross multiply, solve for dx. dx is equal to square root of 2x du. Make our substitution. Denominator gets replaced with u. dx gets replaced with 2 root x du. And if we combine this, we get integral of 2x over u du. So we still have a problem here because this x needs to find a way to be eliminated. So we look at change of variable. We know that u plus 3 is equal to square root of x. Well, first we know that u is equal to square root of x minus 3. If we want to solve for root x, we get u plus 3 is equal to root x. But we want to replace x, so we need to square both sides in order to bring the square root of x to an x. So we get u plus 3, quantity squared, gets replaced in for x. So integral of 2 u plus 3 quantity squared du over u. Now we just look to see how can we clean this up so we can apply power rule. Expand the u plus 3 to be u squared plus 6u plus 9. Distribute the 2 through, split up into individual fractions. And from here we can continue simplifying. This becomes 2u. This becomes 12. And the third term is integral of 18 over u du, which we can apply natural log rule. So power rule first, 2u squared over 2. 12 becomes 12u. 18 over u becomes 18 natural log of the absolute value u plus c. We have our general antiderivative in terms of u. Now we just have to clean this up in terms of x, replace in terms of x. So u squared, we know that u is square root of x minus 3, quantity squared, plus 12 square root of x minus 3, plus 18. U gets replaced with square root of x minus 3. Now, if we expand this out, we're going to have a lot of constants that can merge into this plus c. So if we did that, we would get x plus 6 root x plus 18 natural log absolute value of square root of x minus 3 plus c.